All right. So today we basically did the gravitational field strength, and today we have to do something very important, and it is called gravitational potential at a point. Now this definition comes a lot, so you guys need to basically memorize this. I'll also explain what it means really. So first of all, you should understand that gravitational potential means that it is the work done per unit mass. So that's the first part. And the second part is in moving this mass from infinity to a point within the field. Now, I'll explain what it means, but before that we should know that the symbol for this is phi, then it is a scalar quantity. The formula for this is phi equals to work done per unit mass, and the SI units for this is joules per kilogram, like that. Okay. Now, suppose you have a mass like this. This is the center of the mass, right? So at different points we can make the field. Okay, so let's call this A, B, C, D and E. Now just like we did it before, right? We should remember that at E, suppose that this is the point where the R is at infinity. So because there is no field, we learned that not only G is 0, but also gravitational potential at infinity is also 0 because you're out of the field. But interestingly, this is the maximum value you can reach. So the maximum value of potential is basically 0. What I mean by this is, if a body from the infinity, alright, moves towards the mass itself, then actually the potential becomes more negative. So basically all the values of potential are 0. I mean all of them are negative, and the maximum is 0. And because it's scalar quantity, so negative sign means that the value is smaller than 0, right? If you go from any point towards infinity, right, this means that the gravitational potential becomes less negative. Now we're not saying positive because it's never positive, it's always negative, but as you move towards the mass it will be less negative, it will be more negative, and if you move towards away from the mass it will be less negative. Do you guys understand what I'm saying?
Yes, sir.
Very good. Now, so what happens is that when you look at the formula itself, say, okay, the formula for gravitational potential is given by work done per unit mass, right? Now we need to understand that when you go from one point to another, you're basically changing the potential, which means that the change in potential would be basically if you go from, say, d towards e, right, which is at infinity. So the potential will be like this, right? So we should always understand, like, whenever you go from d to e, or wait a second, d to e or e to d. One thing I want to tell you that's very important to learn actually. So I'm going to write a note here. Note. In scalar quantities, we do not do final minus initial. We never do that. In fact, we always do larger minus smaller. That's what we do. So what I mean by this is, if the potential at infinity is maximum, right? So at infinity the potential is 0, so we're going to subtract the work done per unit mass at any point, which makes the change in potential to be always negative value if it is, not at infinity. Everybody understand this? Perfect. Now, keeping that in mind, then the change in potential can be written as minus W upon M. Work done itself from AS is force times the distance from the center of whatever the mass is divided by M. And the other formula we have actually learned before was that the force is given by GMM upon R squared. So what we're going to do is we're going to replace force there, and if we do that, then we get the final form of change in potential as minus GMM over R square times R upon M. So R and R square will cancel out, M and M will cancel out. That will leave us with only GM upon R with a minus sign. Everybody understands this? So just remember that the change in potential will always be minus Gm upon R, where mass is of course the mass of the body that we're looking at, right? Now, please let me know if you have a question here.
What's the dot you got?
Sorry, come again?
The dot. Okay.
Like in vectors, right? You remember acceleration. Acceleration is final velocity minus initial velocity, right? But in scalars, we do larger minus smaller. Larger means that the largest value of potential can only be 0. So when you do larger minus smaller, so you do 0 minus any potential within the field. Do you understand? Because potential is always negative. Is it clear?
Alright.
Right. Okay, now. So let's do a question and try to understand what I basically mean by this. So in the question, it says that the radius of Earth is 6.4 times 10 raised to power 6 meters. The mass of Earth is given by 6.02 times 10 raised to power 24 kilograms. Now, it asks us a very important question. The first question says that determine the gravitational potential at the surface of Earth then in another part it says state the significance of the negative sign, and in the last part it says explain qualitatively, which means you don't have to do any calculations, okay, the meaning of value obtained with reference to surface of Earth and infinity. So that's what we're going to do, right? Now let's look at the first one now. So we know that the change in potential at the surface of Earth would be minus gm upon r. So it's pretty simple. We just write 6.67 times 10 raised to minus 11. That is the gravitational constant. And then the mass itself is 6.02 times 10 raised to power 24. And then it's divided by r, which is basically 6.4 times 10 raised to power 6. There's no square in it, by the way. If you calculate this is going to be minus 6.27 times 10 raised to power 7 joules per kilogram, or you could write it as minus 62.7 megajoules per kg. Everybody understands this? Right.
Yes, sir.
Now, they ask what is the significance of this negative sign. So we will always say, and this is very important to understand actually, the negative sign indicates the loss of gravitational potential energy. Now you might be able to reference this from your O-level knowledge, right? That when you were moving from, like, you would fall from a height, we would always say, or towards the Earth's surface, we would always say it's losing gravitational potential into kinetic energy, remember?
Yeah.
And when we would throw it away from the surface of Earth, you would say it is gaining gravitational potential energy. So this is the same thing. So when you're moving towards Earth, right, it means, or any mass, it means it's basically losing gravitational potential energy. So that's what we're going to write when moving from infinity to a point on surface of Earth. That's why it is always negative, and now it should make sense to you. And now that you should remember that at infinity, potential is 0, which is the highest value. So every other point will have a lower potential. That's why when you're moving from infinity to a point, you always say that the potential becomes more and more negative. I hope you understand this. Okay.
Yes, sir.
Now the point is, it says explain qualitatively what is the meaning of the value obtained. The value minus 62.7 megajoules per kilogram. Basically this means that it is the amount of gravitational potential energy lost when 1 kg mass falls from infinity to surface of Earth. So this is the amount of energy it has lost. Do you understand now? Nashima, Moise, Suman, Hassan
Yes, sir.
Atiq, Rafe.
Yes. Okay.
Excellent.
Sir, a question.
Yeah.
So if it's going towards infinity, it's going to be positive.
It's the value means the change will be positive, right? But the actual value, like if I say okay, at the surface, right? At the surface is 62.7 minus, right? At this point it might be 30, it might minus 30, it might be 20. The value at this point will be 0. So basically you can always reach 0 or a negative value. But yes, if you talk about the change means that if you go from A to B, then the change will be positive, which means you have gained potential energy. Do you understand?
Yeah.
That's very good actually. Okay. Now, the thing is that we've talked about this a lot, right? And this time, basically I need to copy this actually. Sorry. I'll copy this because save some time. And then I'll erase the other things. I don't need that. Okay. No need. Copy. Now the next question is basically the basis of all questions that are going to come here. And the questions are super easy if you grasp the concept, right? And if you understand that what I'm gonna do if it moves away or towards the earth or any mass, right? So then everything becomes so easy for you. Now, suppose that this is our earth, and just like in the previous question, right? We know that at the surface, the potential, the change in potential is minus 62 point, or the potential is minus 62.7 megajoules per kilogram, right? And at infinity it is 0. Now, I'll write S here just to differentiate it. Now, we must understand that this distance, right, from here till here, it is the radius of Earth, right? And from this point to D, so let's go towards D. They say this is like, okay. Oh, I made a mistake here. Till C. This is 3R more, okay? Now at this point, they have said, so I'm basically doing an example. This point there is a mass which is placed here, okay? The value of the mass is 42.8 kilograms. And now they say that an object falls from distance of 3r above the surface of Earth to the surface of Earth. Okay. If the mass of object is 42.8 kilograms determine the work done in the process. So basically we are looking at how much gravitational potential energy it will lose, right? Now, so first of all, we need to follow some steps here to understand what we are really going to achieve, right? Now, so step one in these sort of questions, basically these questions will be every single paper. If there is a potential question, this question will be there, or similar question. So step one is always find the potential at starting and ending point. Now the end is the surface, and we already know the potential at surface, which is minus 62.7. So we need to know the potential at C, because the potential at C, if we get it, then we can find the change, right? So we are looking at the potential at C. Now he has given some other things as well, which I forgot to write. The radius of Earth is 6.4 times 10 raised to power 6 meters, and the mass of Earth is basically 6.02 times 10 raised to 24 kilograms, like that. Okay, now the second thing you always should remember, well, in fact, I'll write a note here, and this is a trick they will play all the time, that the distance from Earth to C is not 3r. It is 4r. Why? Because we must always take distance from center to center. Is it clear? Never ever take distance from surface to center, always from center to center. So basically you need to add this, which means the real distance from this is this much, which is basically 4r, not 3r. Everybody understand this?
Sir?
Yes.
So what's the radius of the smaller object? Should we add that too?
It's basically so small that we don't really care about it, right?
Okay.
Yeah. If there are two bodies which are really big, right, and then we will take center. Is it clear? Okay. Now,
Yeah.
so doing step one is that we have to find this. Yes.
I'm sorry for interrupting, but can you explain the 4R particle?
Yes. So basically, the distance that they have told you in the question is that the object falls 3r above the surface of Earth. Do you understand what I'm saying? In
Yeah.
fact, the real thing is that it's not about the object falling from 3r. The distance will always be from the center of Earth to that point. Do you understand? So
Yeah.
the distance is always taken from center to that, which makes it 4r, not 3r. So that's a trick they will play all the time. Okay?
Okay, thank you.
Now, so step one was that we want to find the potential at both points. One of them is already found out from the previous question. One we need to find. So the potential is given by minus gm upon r. So this will be minus 6.67 times 10 raised to minus 11. The mass of Earth is 6.02 times 10 raised to 24. And now the distance will be 4 times 6.4 times 10 raised to 6. A lot of students make this mistake. They write 3. So avoid that. Now when you get the answer, this will be minus 15.7 megajoules per kilogram. So this means that at this point the potential is minus 15.7 megajoules, okay, per kg. Now then we move to the step 2, which is find the change in potential. So change in potential, because this is scalar, so what do? We always do larger value minus the smaller value. Okay, in scalars we always follow this rule. So what you're going to do is the change in potential from falling from C to the surface would be actually the change in C, the potential at C minus the potential at surface. Why am I saying C is bigger? Because minus 15.7 is a bigger value than minus 62.7. Okay, that's why. So when you write it this way, minus 15.7 minus, and now you take 62.7, and this is basically all of it is in basically megajoules per kilogram. So you get about 47.0 megajoules per kilogram. Now this is the change in potential that has occurred for that mass to fall from C to the surface. Now the third step in this question would be that use potential equals to work done upon mass to find the work done. And that's pretty simple, right? So what you're going to do is you're going to write the potential is equal to work done upon mass. So we want to find the work done, which means the change in potential times mass. The change in potential is 47 times 10 raised to power 6. So I've changed it into basically joules. That's all. Times what is the mass of the object that's falling. So the mass of the object, it was 42.8 kilograms. And now if you use your calculator, well, I think I've calculated this value already, so wait a second. So this will be 2.01 times 10 raised to power 9 joules. And if they ask you what is the significance of this, we could always say that yes, this is the amount of gravitational potential energy that it has lost. Do you understand?
Yes, sir.
Take a nice look at this question again, okay? If you have any doubt still about the steps, about what I've done, please let me know. Okay. Now, if he says, okay, draw a graph of this, right? So we can actually do it pretty easily. That's not very hard. So graph of gravitational potential. Now one thing we should always understand is because the gravitational potential will always be negative, so this means that the graph will be like this, inverted. And this will be the gravitational potential, which is joules per kilogram, always in negative. And here, this is R, basically in meters, right? That's the distance. So if this is the surface of Earth at R, so we're looking at the distance at 4R, right? From the surface, from the point where R is 0, right? And this is the potential 0. So at R, we should remember that the potential at R was actually 62.7 in minus, because I put a minus sign here, so I don't need to put it again. And I need to basically not write joules here. I should be writing basically potential as megajoules. Okay, and put a minus here, it doesn't matter. Now, so the graph would actually go like this. Okay, great. It will approach 0 because at infinity it is like that. And at 4R, go straight up, the potential is minus 15.7. Do you guys understand how the graph looks now? Now, the axis this graph will never ever touch the x-axis. Why? Because at infinity it is 0 and we don't know where the infinity is. Do you understand? Also, if you ever forget about the graph, you're like, okay, I don't remember what exactly it was. So you should always remember, because the potential is given by minus gm upon r. So basically g and m are constants. So potential graph is proportional to 1 upon r with a minus sign. So 1 upon r is always a downward curve, and the negative just flips it. So it's basically like this in the negative quadrant. Is it clear?
Yes.
Right.
Sir,
Yes.
does the gradient tell us any?
The gradient.
Yeah.
The gradient of this graph, well, they won't really ask you this, but it's something complex. So, no worries
Okay.
about it, okay? Okay, please draw this while I pose the question. Okay, the class is going to stop automatically in like 2-3 minutes, okay? So, you'll join the same link again once it's stopped.
It's a double class?
No, I just need your 10 minutes extra.
Okay.
Today.
Right.
Because if I don't finish this, I will be very uncomfortable throughout the day. That's fine.
Sir, can you scroll up?
Yes.